Hi. I'm Sarah May. I was here last year. I did a talk last year. So I feel like I know half the room already. But in case I haven't met you already, I'm Sarah. I run a consulting company called the Ministry of Velocity in San Francisco. I spend most of my days helping people refactor large code bases. And I wasn't supposed to be up here this year. I was on the MountainWest program committee, which meant I got to read all the proposals that people sent in, which was pretty cool. And I think we did a good job coming up with a program. I mean, do you agree so far? Seems okay? All right, good. However, as a program committee, there was one critical thing that we failed to do, and that is allot sufficient backup speakers. So that's why I'm here. I'm actually really excited to be here. I did this talk last week at a conference called Fluent, which is a JavaScript, CSS, HTML conference in San Francisco run by O'Reilly. Here's a picture of that conference. You can tell it's an O'Reilly conference because they sprung for the expensive, no-flip name tags, right? Apparently that's what the extra $600 in the ticket price gets you. Fluent is not the type of conference I normally do. I'm normally hanging out with Ruby developers, usually people who consider themselves either back-end developers or full-stack developers, which is a totally different crowd. So I spent a lot of time at Fluent wandering around and talking to people and interrogating them and making them tell me why they went there. So the people I met fell into three categories. First, back-end developers who were there to learn more about front-end development because all the cool kids are full-stack developers these days. There were visual UX people who were coming at front-end development from the other direction. And of course, the biggest group of people were front-end developers who were there to learn more about what they do. So these are three groups of people with very different past experiences. And what surprised me is that when I asked about specifically why they were there, they all told me the same thing. Here's some quotes. Let's see if any of them sound familiar. My group has started an Ember project, so I'm going to every Ember.js talk on the schedule. My web app has an old jQuery code base, and I need to figure out what to do with it. One thing that I learned at Fluent is that there are some people that really, really, really hate jQuery. I want to learn about Angular. I think I can raise my rates. Almost certainly true. And finally, we have an ancient Backbone.js setup, and we need to rewrite it in something cleaner. And I think by ancient here, she meant 6 months old. So what was interesting is that no matter what direction these people were approaching front-end development from, they all had the same question on their minds, and that is, what JavaScript framework should I be using? And I imagine this is how I look when I try to solve this problem. And this is one of the big open questions in web app development right now, right? How many of you in this room are thinking about that as part of your work, right? Everyone's thinking about it. It's an open question because of this. I mean, not because of Ember, but because of this. Wait for it. There we go. This is a great problem to have, right? There's so many options. Unfortunately, there are so many options. And even though it seems like these days we have some front runners emerging, it's still really early, right? I mean, Ionic, which is the upper left corner there, they just got $1 million of funding last week, right? So very early days, very confusing. And every technical community has questions like this, right? Things that everyone is writing about and they really, really want to tell you their opinions on. For example, one of the other questions that we as Rubyists have at the moment is, what data store should I be using, right? Postgres or Mongo or Cassandra. So many choices. And when you're a developer with a specific project in mind, it can be hard to tell what the right answer is. And the internet has a ton of information about this stuff. Unfortunately, the internet has a ton of information about this stuff. And it's really hard to sift through and find the things that are useful. So here's a fun fact. If you Google how to pick a JavaScript framework, as of last week, there were 2 pages of results for the last 6 months. Unfortunately, all of these things taken together are about as helpful as this collection of parking signs. So I want you to look at that and tell me whether or not you can park there at noon on a Tuesday. And I'm not going to wait. These blog posts and things give you contradictory and confusing information. And that seemed to be the case even at Fluent, right? I'd go to one talk, and it would be Ember is so amazing for X, and then in the same room, in the next time slot, was an Angular talk that was Angular is clearly superior for X. And your job is to synthesize all of this data into a decision. No pressure, right? But it's really important because the cost of being wrong is high. It's not just, are you parking illegally? Might you get a $30 ticket, right? It's like if you pick a JavaScript framework that isn't suited to your project, it can be pretty disastrous, depending on when you find out, right? How far down the road do you go before you realize there's no more road? So these decisions are big, and they're scary, and we want to be able to get better at them. Unfortunately, we don't make these decisions very often. And one of the most effective ways for our human brains to learn is by repetition. So I'm sure that you have heard this before. Because in programming pop culture, we've got a particular meme. We have this one. I found this inspirational image on the internet. Right? The meme is, it takes 10,000 hours of practice to get great at something, like playing an instrument, programming, or whatever this person is doing. And it actually makes me a little bit angry every time I see this, and not because of that horrendous drop shadow on the text, although that is pretty bad, you got to admit. It makes me angry because it's such an oversimplification of how people learn. I could do a whole talk, and I actually considered it, and you're lucky I didn't, about how much misinformation is just in these 2 sentences. So we're not going to do that. But the meme is persistent partially because it has a kernel of truth in it, which is that repetition is powerful. The key, though, is not just time spent, it's how you spend that time. You can spend 10,000 hours on something, but if you're not doing it right, those hours are wasted. To learn by repetition, you have to do the action, analyze the outcome, repeat the action, changing it a little bit, that's the important part, changing it to see if that changes the outcome. And even once you think you've got it, even once you think you can do that perfect cursive letter L, you need to keep experimenting, keep trying new things, and that's where the learning actually happens. As a side note, my daughter is 8 years old, she's in 3rd grade. They don't teach cursive anymore. I was shocked. At all. They don't do these worksheets. I remember doing these worksheets as a kid, which makes me feel old. But she has, however, known how to operate an iPad since she was 2, so I guess I'm betting that that will be a more useful skill in the new world, but we'll see. So repetition is a way that we can get better at something like large-scale technical decision-making. If only we did it as often as Noah is doing his letter L's, right? If only we could wait 10 years or 15 years to accumulate more experience with this type of thing. Yeah, can't do that, at least not right now. But we can make an end run around this limitation by analyzing the decisions we do make all the time and bringing that intelligence back to the framework choice, because our decision making happens at different scales and different frequencies. So language and framework choices are the most infrequently made decisions, but there are a few things we do more frequently, such as decide whether to use some random code you found on GitHub. And even more frequently than that are the technical decisions we make every day, which are things like, where does this code go? What should I call this variable? Should I write a test now? But even at the smallest, most frequent level, the process we use to make these decisions is pretty opaque. If you ask a programmer why they named a variable a certain way or why they put a function where they put it, often the best thing they can tell you is, well, it seemed like the right thing to do. Sometimes you get answers like experience, intuition, gut feeling. When I ask one programmer why they like Ember over Angular, or the other way around, I get very similar opaque responses, right? I get things like, it feels more natural. And I've heard that from both sides, by the way, from different people. So I wanted to investigate what goes into that feeling, right? Like, what data do we collect? How do we organize it? What do we do with it? Because we want to get insights into these. So we're going to look at these, because it turns out that you and I both know a lot of people who evaluate random code off GitHub all the time. So I asked a bunch of my colleagues to introspect for me and describe how they evaluated gem that they're considering using in their project. And it turns out that everyone starts in the same place, which is that they go to GitHub and they read the README. Now, this is a README that predates GitHub somewhat. It is from 1936. It's a README about how to operate the telephone. So when people come to a README, they're looking for features, functionality, usage of the code. They're looking for the interface of the gem. What does it do? How do you use it? And this information is usually easy to find because it's in bullet points right there in the README, right? To operate, to answer, to clear, to make calls. So let's consider an example evaluation and walk through what this looks like. Let's say you're trying to pick a gem to make HTTP requests. So we all know that making HTTP requests is how you use the tubes that make the internets. So we need a gem, so we do some Googling, and we find two contenders. We find HTTP party, which I'm not sure I'm pronouncing correctly. In fact, I'm pretty sure I'm not, and Faraday. So assuming you don't dismiss HTTP party because you don't like saying it, you can look at the README, you look at the usage section. This is what you find. You don't need to actually read all this code. I'll point out the interesting bits. HTTP party has static methods you can call, or you can include its module into your own object and have HTTP methods as instance methods. Faraday takes a different approach, gives you a connection object that you can use to make the calls. So both interfaces will work. Both will allow you to make any HTTP call you need to make. So this by itself is not enough to make a decision, just like the bullet list of features of a framework aren't enough to tell you whether it's worth using. So what else do we think about? Here's what I got from interviewing a bunch of people. Everyone pretty much starts with a README. And you can tell this is going to be a scary slide, right, because the font's so small. Are you ready? Here we go. It's a long list. They look at the frequency and recency of commits on GitHub. They look at how many issues there are and how old they are. They look at the comments to see if the maintainer's an asshole. They look at the number of recent blog posts about it. They look at Ruby Toolbox to see how it compares to similar gems. They look at the date of the last release. They look at Stack Overflow to see how many questions are about it and how many are not answered. And they ask a bunch of people. They ask work colleagues. They ask Twitter. They ask Hacker News, which seems like a really bad idea to me, but some people do it. They ask other developers. They look at the official docs. They look at books. They look for screencasts. Sometimes they read the code directly or read the test directly. Sometimes they just try it. Or if it's important enough, maybe they'll build a sample app around it. So this is not an exhaustive list, but it's pretty much the union of what everyone told me about how they pick a gem. And I want to point out a few interesting features of this list. The first is that different people rank these differently, right? So everyone pretty much pokes around on GitHub first. And then what I do after that is I usually ask my work colleagues for input. But one of the people I talk to works at a company where it's a really bad idea to display any kind of ignorance. So as soon as he looks at GitHub, he goes straight for like official documentation. So that's the first thing. The second thing is that no one does all of these for any given evaluation. But the riskier a decision is, the more of them we do. And the last thing is that this list changes as the community that generated it changes. For example, before Rails came along, a lot of discussion about Ruby libraries took place on the official English language Ruby mailing list. But today, I don't think it would occur to any of us to post to the official English language Ruby mailing list if we were trying to pick an HTTP gem. And different communities will generate different lists. If we were to generate this for Python, for example, there would be a lot more mailing lists on there because that community depends much more heavily on mailing lists. So all of these things, I'm just pointing out that the way that we collect and use this data is pretty complicated. And the most interesting thing, though, is that if you eyeball this list, you'll discover that most of it isn't technical data. When we think about evaluating code, we think about looking at the code, and we think we're making decisions based on technical things, but most of the data up here is social. It's information about the people around a project, the maintainers, the users. There is some technical data here. Let's see if we can we'll pull that stuff out first. This is the interface. It's like the external interface of the gem. And then these things are all information about the activity of a project. How often is it updated? How likely am I to get help from a maintainer, get a pull request merged? Pull those out over here. Give ourselves a little bit of space here. So what's left? Well, all this stuff is information about the project's popularity among other developers. How easy will it be to find help when I run into a problem? Can I hire someone who already does this? How likely is it that someone else has already fixed a bug by the time I encounter it? So we'll pull that stuff out over here, and now we are left with a couple of outliers. And these are reading the code and reading the tests, which don't really fit into any of the groups we have so far. Right? Interface, activity, popularity are all pretty straightforward, well-known sources of data for all that information. But what we have left is a little fuzzier. It's really about how familiar things feel to you. Right? Is this code idiomatic Ruby? Does the maintainer share my test strategy? How much does this code match up with what I would write if I were going to roll my own? How much does this code feel like other code I've seen? So I want to call this accessibility. So there's our last group. These are the 4 categories of data that we think about when we're making a decision about a gem. Once I got to this point in my presentation, I kind of squinted at them for a while. And I realized you can actually group these in two different ways. So stay with me here. We're about to make quadrants. It's going to be amazing. Apparently this is a thing. So here we go. First off, you can draw one line here. The two categories on the top, accessibility and interface, are both about you. Interface is about whether the code can do what you need it to do for your project. Accessibility is about whether your team feels comfortable with the metaphors the project uses. And on the bottom, popularity and activity are about the people and project outside of your team, external factors. So we have our internal, we have our external. We can draw another line, of course, right there, because I kind of gave it away. We're already doing quadrants. And on the left side, accessibility and popularity both have to do with the people around a project. Right? Accessibility is whether or not your people can use it. Popularity is whether or not other people are using it. And on the right side, interface and activity are both information about the project itself. Right? The interface, as we said, right, is whether the framework or whether the project does what you need. And activity, while it is generated by people, is ultimately about the project. It's about whether or not you can bet on bug fixes and improvements down the line. So there you go. There's my 4-quadrant system for making difficult technical decisions. And I was showing this talk to a friend, actually. We got to this part, and he was like, this is awesome. Because you know, consultants are supposed to have a system they're selling. And I was like, what? He's like, now you've got one. And I was like, huh. He's like, but you got to give it a name. It's not going to catch on unless you give it a name. And I thought, okay, if I'm going to own this, I'm going to own this. We're going to give it a really narcissistic title. You ready? Here we go. The May system. And you know, if this really actually does make you want to throw lots of money at me, let me know, I guess. But otherwise, I think I'm just going to stick to my pair programming approach at the moment. So far, maybe this isn't super useful, right? All we've done is capture the practices that people actually do and put them in categories. And categories, while they can be useful, right? These seem very useful. They really only become powerful when we apply them to the higher risk decisions. So let's look at how to apply these categories to higher risk problems. I mean, not these categories, although that seems like it would also be an interesting talk. These categories. Let's start with interface. The interface of a framework is pretty straightforward. It's what's in the Angular README, it's what's in the Ember README, it's what's in the intro tutorials. These are the bullet lists of features that make up most of the blog posts and talks and so on about picking a framework. Next, activity. Activity is largely the same as at the smaller scale, right? You can get this information by looking at the GitHub project, looking at the release schedule, looking at the docs. So popularity, also largely the same. Stack Overflow content, percentage of hacker news arguments, number of recent blog posts. And finally, accessibility. So this one's a little bit different. Once again, it's kind of the interesting one. Because if you look over the JavaScript framework landscape that we have today, there are multiple frameworks that have a sufficient interface, are sufficiently popular, and have sufficient activity. Right? This is basically where we are today. Backbone, Angular, and Ember. All three of these will do what your application needs. They're all reasonably popular. They're all reasonably active. Accessibility is how we distinguish these frameworks from each other. So to make this more concrete, I want to show you what an accessibility judgment looks like at the small scale and then at the large scale. So let's go back to our HTTP library example. Both of these libraries have a sufficient interface. They're both actively maintained. They're both heavily used. But they feel different to use. And we can sum up the difference this way. HTTP party lets you add call functionality to your existing objects. Faraday lets you keep call functionality in a separate object. So if you come from a procedural programming background, then the upper approach will feel more natural. It'll feel more convenient. But if you've done a lot of object-oriented programming, maybe you've drank the single responsibility principle Kool-Aid, then the lower approach feels better. And that's what accessibility is all about. Do you identify with the style of the code? And that's even more important when you're talking about frameworks, because those will affect the code you write way more than an HTTP gem will. But at the framework level, it's not always easy to untangle what an accessibility judgment comes from. But let's try. Now that we've seen what accessibility means on the small scale, let's look at what it means on the larger scale. And I want to start with a little history of how Java and JavaScript have historically gotten along, which is not very well. So for a long time, Java Web Framework land was a very sad place to be if you were JavaScript, right? The state of the art for a while was something called Java Server Faces. I don't know if anyone remembers those, because they're not on my resume anywhere, and please don't ever ask me about them again. They are packaged front-end widgets, usually with a really old version of jQuery thrown in there. And to put one on your page, you put a little directive into your markup, and it spews JavaScript into your page. It hooks up automatically to your backend, and you get JavaScript functionality in your web application without having to write any JavaScript at all. And that was a feature. So for years now, the Java community has put a pretty intense amount of effort into avoiding JavaScript entirely. There were other efforts, right? There's Gwt. Anyone remember Gwt? Google Web Toolkit. You write Java, compiles down to JavaScript. There's more modern approaches, right, like Dart. And these are all basically efforts to allow Java developers, right, of which there are millions in the world, write JavaScript without actually having to learn it. However, in Java land these days, there's a new contender, and that is AngularJS, written by Java developers, and featuring a dependency injection structure eerily similar to those found in modern Java backend web frameworks. So if you come from the Java backend world or the .NET backend world, where dependency injection frameworks are standard operating procedure, Angular will feel very familiar. It'll feel accessible, right? It'll feel easy. It'll feel normal. Now, it's a huge step forward for the Java world, right? They're actually writing JavaScript. That's great. Awesome. But it has a structure layered on top of it that makes it less risky for them to adopt, because they can do JavaScript without having to learn an entirely new development paradigm, just new syntax. Now, conversely, for those of us who don't come from Java or .NET, the dependency injection in Angular can feel a little bit disorienting at first. Maybe fun, right, but disorienting. And that makes adoption for us riskier because we have to take on the cognitive load of understanding the framework in addition to trying to actually get shit done. Now, of course, there's a learning curve on any JavaScript framework for any team. But finding a framework that fits the way you already think makes adoption of that framework less risky. And that's what accessibility measures at its core, right? It's a measure of how steep the learning curve is likely to be for your team. So let's talk about Ember.js with a mascot that I think we've decided is a hamster. And it's not quite as creepy as the Go gopher. I mean, I don't know if you've ever seen the mascot for the Go programming language, but this may be the creepiest conference logo I have ever seen. Wow. All right, anyway, back to our friendly hamster. Ember.js, built by Rails developers, featuring at the center of all Ember applications a router, a piece of code that takes in a request and decides what code to run as a result. Eerily similar to what's at the center of all Rails applications. The concept that the routes determine what code gets called flows from REST. So if you come from a framework that matured in the RESTful era, such as Rails or Django, Ember.js is going to feel very accessible. It'll feel easy. It'll feel natural. On the other hand, if you come from Java or .NET or another web framework that matured before REST was a popular thing, then you're used to having much more control over exactly what happens during a request. So Ember may feel a little bit overly constraining. And finally, we have Backbone.js, sort of the granddaddy of all of them. Backbone was graduated out of a Rails app in the 2008-2009 timeframe. And I know it's hard to think back that far, but that was before the idea of single-page apps was really a thing. There were one or two people doing things with like cappuccino over in a corner somewhere, right? But most people thought about JavaScript as something that decorated server-rendered pages. So you'd render a view, assemble some JavaScript, shove it down the pipe to the client, and then once they got there, the JavaScript would add a veneer of interactivity to the markup. And if that's how you still think about web applications, then Backbone will feel pretty natural. It'll be easy, it'll be straightforward, maybe not convenient at times, but certainly understandable. On the other hand, if you're one of those kids today who thinks about a web application as a bunch of JavaScript that runs in a browser, creates some markup, and goes out to the internet to get data once in a while, then Backbone feels completely wrong. So for this framework, the accessibility judgment flows from the type of projects you've done rather than the technologies you've done them in. And that's interesting, right? What we're seeing is that accessibility judgments come from many different sources when we're talking about frameworks, because frameworks are much more complex than a simple gem. So one source is the technology stacks you've worked with. Another source is the type of projects you've done. It can be influenced by the people you've worked with, all kinds of different things. And for any given decision, accessibility is the most difficult to figure out sometimes, because it's not like the Angular guys have a bullet point in their README that's like, written by Java developers for Java developers, right? Everyone who's building a framework thinks they're building it for everyone. And they're all wrong. What they're actually doing is turning the way that they think into code. So I guess from a practical standpoint, the question is, how do you see that? I mean, besides coming here and letting me rant at you. I mean, as fun as it is to talk about it, you probably don't actually need to know what their biases are when you're making a decision, because you'll be able to feel how well they line up with yours. What you do need to do is notice the amount of ease or unease that you feel when you use a particular framework. And remember that even once you're explicitly thinking about accessibility, it may not always be the most important factor in a decision. Sometimes you have a team that's overtaxed, and you need a way to adopt a new technology that is as close as possible to what they already know. But other times, your team is ready and willing to be pushed further. And sometimes you want popularity because you know you'll need to hire 5 people in the next 4 weeks. But sometimes you pick something totally unpopular and new because it has that one feature that you need for this project. But when you're making a decision, just make sure you're actually thinking about all 4 quadrants. Now, I want to close with something that I read on Hacker News last week. Steve Klabnik reads Hacker News, so I don't have to. Thank you, Steve. The context is a blog post about Nimrod, which is an obscure programming language. And one of the commenters talks about all the great features it has, how great its interface is. And then he says, the only reason Nimrod isn't popular is that people don't evaluate things logically. He was clearly very frustrated. And I really sympathize with that point of view, because the decisions that other people make really do look mysterious if you think that this is all there is to think about when you're evaluating a technology. Nimrod is failing to catch on, but it's not because people are illogical. It's failing to catch on because their logic extends further than that guy can see from like down here. So even though we can't repeat the language or the framework decision often enough to learn from repetition, we can take these categories and let them expand the vista of things we're looking at when we're thinking about a large-scale technical decision. And as a very wise man once said, change of perspective is worth 80 IQ points. Alan Kay just, invented object-oriented programming, that's all. So, and I would say with the things we're talking about, a change of perspective is worth 80 IQ points and about 5 years of experience. And that's all I got. Thank you very much. I have one other thing I have to do. I'm trying to make sure that no one can ever tell me apart from Sandy Metz, so we are going to write a book together. It's about how to refactor large Rails apps. So you can go to practicalrailsbook.com if you're interested. Thank you.